Pharmaceutical Processing, in conjunction with INTERPHEX, presents INTERPHEX Live.
We're going to be talking about adding intelligence to legacy assets through artificial intelligence, okay? Actually, if you had been here for the last session, this was something we talked about quite a bit, so hopefully the connection was made. Helping us out here is Blair Fraser. He's the leader in digital transformation at Lakeside Process Controls, okay? So we're going to take it from here. So let's start, what are some of the, my first question is artificial intelligence, all right? Let's just, let's just frame that one out first, okay?
Yep.
So let's talk about what it is, and then we'll get into the nitty gritty with that. From your standpoint, go ahead.
Sure, so artificial intelligence is, it's to me, and I have no background in artificial intelligence other than co-founding a company that does artificial intelligence. My background is not artificial intelligence. I'm an engineer born on the shop floor. So I'm not going to give you a description of artificial intelligence from the deep-rooted technical, right? What it means to me is it's finding relationships, correlations, and patterns in data that humans cannot find.
Right. Well, that's good, because I tell you, as many Microsoft commercials on AI that I've seen, I'm always left with, I get it, but what is it,
That's exactly it, and to give you an idea, the average human can look, and the average human is a general statement across the world, the average human can look at about 4 trends on time series data and make correlations with that data. So just 4 trends, right? And AI, I like to think of AI instead of artificial intelligence as augmented intelligence.
Okay.
Right, because there is different levels of AI, and what we're dealing with, and I think what industry needs to adopt is a very narrow focus of AI, specifically machine learning, which is allowing us to look at that data and input more data augmented by our subject matter expertise.
Okay, great. So one of the things that came out was a lot of times that augmented reality, when it's all about trending and looking at things and maintaining process control and make sure that is right in the center. So what examples, like in artificial intelligence, that can do like alarm monitoring and trending and charting in our industry? That's key. So how would I use that?
So typically where we see applications coming in is a continuation of what was called Industry 3.0, right? So a continuation of that existing automation that already exists and advancing it to the next level. So the analogy I give, and it does boil it down to a very superficial level, but if you imagine if an asset in your facility could talk, I know this is a stretch, but if it could talk to you, right? If you could walk up to it and ask it a question and it had the ability to answer it, what kind of question would you ask? And I've done this for the last 2 years. And I usually get, well, first of all, it depends who I'm talking to, I get 3 answers. The first one is, well, that's not possible, and the person can't get over that. But the majority of them are, I love to, when I go into my plant in the morning, go up to an asset and say, how are you feeling today? Okay, so that's one. The other one is, how well are you going to do for me today, right? And those first 2 answers are different applications from artificial intelligence. The first one is, how are you doing today, is really a reliability. It's an OEE, operational equipment effectiveness type discussion. Are you going to break today, right? The same way when you go to a doctor, right? Feeling kind of sick and things like that, right? So its ability to answer that through data can only be done through artificial intelligence. And the other output of that is, how well are you going to do for me today? There is a reliability aspect of that, but what we're looking at is things like, what is my quality of my end product or my yield going to be at the end of this batch, right? And we've had statistical models to do that, and some have worked out great. But really, artificial intelligence is just a continuation of the great technologies like the analytical technologies already exist today, and this is further complementing to that. So we can answer that question, what is my batch quality going to be like 3 days from now, 3 hours from now, 3 days from now? And of course, when you answer that question, I could probably give a good answer to 3 hours from now. 3 days from now, that answer is probably not going to be as confident, but it's going to get me somewhere, right? And when we look at how are you feeling today, the end goal of that is, when that machine answers you, is, I'm going to break in 3 days, so you should probably schedule some maintenance, right? And that's the holy grail of remaining useful life. But the value, specifically in pharma, is if I tell you, hey, this pump, this steam trap is starting to act abnormal, right? It's not affecting production or quality yet, but it's starting to be not so right. It's like, my elbow kind of hurts, right? Chances are, during a planned maintenance instead of reactive maintenance, right? You're going to go and look at that further and change it out and do things, right? So it's all about that guided maintenance process.
Okay. All right. So I think that's good. Because, see, I was actually going to ask you, because we maintain products in what we call a design space. But I think it's best we approach AI from the standpoint you're looking at. Let's start at the basics and move up.
Absolutely, yeah.
I think the design space is a stretch.
So there's a lot of opportunity from the design space, and anyone that's going to watch this or hear now that's looking at, putting new capital equipment in, my recommendation is design for Industry 4.0. So look how you're going to get that data out, because everything is fed by data, and it's not necessarily the data that we're used to capturing. We're talking about data of every valve opening and closing, stuff you really don't have to historize from a GMP compliance and things like that you wouldn't normally do anything with. But that data is the new gold, essentially, right? But I gave the analogy of anomaly detection and things like that, is you get one chance of an asset to capture its birth certificate. This is what it was from, when an OEM builds or you design it, that it's brand spanking new, right? Capture that birth certificate. Capture everything you can with that data, because that data is going to be so beneficial. And one of the biggest struggles we have from legacy equipment is, if you haven't seen it, how do you predict it? Right?
Yeah.
So capturing data the whole way through, even, in my opinion, data storage is cheap now, right? We don't have to be pick and choosy about what we store. So if you do have a new capital asset, at least put the foresight in to say, I want to capture that. I want to capture it from our factory acceptance testing, when we're simulating failures, when we're just putting water through to see what happens if this pump was to shut off, and what's that effect on my process.
I guess then my question, to me, I'm all in but to me, people are apprehensive about AI. So
absolutely.
Give me something to arm me. How do I convince people is the route to take?
So first of all, and I've had these conversations where we're looking at doing things, and I give that analogy. If you were to ask your asset a question, what would you do? And provide solutions that don't even say, hey, we're just finding relationships and patterns in your data that you didn't know existed, right? And kind of weave in the fact that it's artificial intelligence. But to me, one of the biggest fear of adoption of artificial intelligence is how do you trust it? Because really what artificial intelligence is doing is, it is automatically finding those correlations and patterns in that data, right? And it literally could be a black box, where someone else has trained this model, right? Put it in there, and it's giving you recommendations, right? And if I was to receive a black box and say, in 3 days this is going to break, or your batch quality is going to be less than desired, I am probably going to say, why are you telling me that, right? Why would you say that? Everything else, from what I can see, is good, but this stupid black box is telling me it's not, right? So it comes down to a trust issue, and the analogy I give was, most of us, if we drive a car, have a miles to empty calculation, right? Mm-hmm. And if you're anything like me, you have tested the limits of that miles to empty, right? You've gone down to 10 and it's beeping at you and you keep on driving, right? To the point where it says 0 miles to empty. And that point you're thinking, I got free gas. This is amazing.
Yeah.
Right?
My wife considers that validation of that system.
That's right.
Actually, yeah.
So when
it stops, we know it works.
That's right. You found out how far you can go past that miles to empty, right? And studies show that miles to empty, depending on the manufacturer of the car, can be up to 30% off. 30%, right? Which is a high number, and that's probably why I don't trust it. Right? I may get behind a truck and try to drift a bit and put it in neutral to get down the hills, but I don't trust it, right? Yeah. It's a good indication, but I don't trust it. Now, if you were to use that analogy, and I, for some reason, was an expert on fuel economy, right? And I designed that miles to empty, right? I knew that miles to empty depended on my outside air temperature. It depended on how clean my air filter was, how fast I was going, how much load I had in my car, what's my tire pressure, right? And I built that, and I put that in my car. You better believe it that when I'm driving it and it gets to 10 miles to empty, I start to get white-knuckled in the shakes, right? Because I trust it, right? And I think that's the biggest adoption of AI, is putting that subject matter expertise. A lot of people think is, I can go to data scientists, and I can just give them the data, walk away, and come back with this magical solution. And that's
Right.
not the case. And that's what I think is great for us as the people that operate, maintain, design these pieces of equipment. Without us knowing that process and what happens and making sense of that data and guiding the data scientists, or using a platform that inputs that knowledge to knowledge discovery, really is going to break down that trust issue. Because when that black box tells me, hey, something's going to fail, I know, hey, these are the values it's using to give me that output.
Right, right. If you remember, I think one of the things on the trust issue, if you recall, when there was a time where pushing to the edge of failure was considered where you should take validation, and we've kind of gotten away from that. We're back into the design space in our sciences, where all the process inputs. So I think, yeah, as an industry, we like to see when it breaks. I mean, that's what gives us the confidence. But to me, I think where the real issue is going to be is maybe if I'm greenfielding it and I'm buying everything brand spanking new and I'm getting the birth certificate, great. But I think we're talking about legacy. So I got a feeling that's where a lot of mistrust is going to be, because I don't know the lineage of this thing.
Absolutely, yeah, yep.
So when it comes, so how do we put the AI in that situation?
So yeah, with legacy assets, it's difficult because it hasn't been designed to capture the frequency, the velocity of data that is often required. And it's different between, if you're looking at a fermentation process that's 3 days, the velocity of which you need data is a lot different than if you have a high-speed packaging or filling line, right? And we've done projects for a high-speed filling line where it's every 10 milliseconds we're capturing this data and making predictions, where a fermentation process, we can capture it every 10 minutes, 15 minutes, 30 minutes, because it's a biologic process and nothing happens really quick, right? So the problem with legacy assets is just that, right? Is how do we connect this data, right? And any of you that have these legacy assets, you might, you open the control panel, because typically you haven't designed your data flow to capture the signatures of a torque value from a servo motor, or the valve opening and closing signal. It doesn't go anywhere, right? So you need to start thinking, how do I get that data out, right? And it's one of those ones where you open the cabinet and you're like, oh gosh, right? And you close that cabinet because you don't want to touch one of those wires, because that PLC is 30 years old, right? And those type of challenges, right? And the systems weren't built like today, and I think that's great change in industry. Is end users are requiring the vendors to be open sourced. Allow me to get your data out, which I think is great, right? Is how do we get that data out? And that's why we've designed specific edge protocols to connect directly into those protocols, those Allen Bradley 20-year-old PLCs, right? And not necessarily communicate with it, but just extract that data, right? Chances are, when you're looking at legacy equipment though, and the how I typically start a project was get the person that knows that piece of equipment day in and day out, right? And they might not be your typical engineers. They may be the operator that just feeds trays in, right? Is if that person and their whole job was to sit there and look and listen and feel for that machine, they just sat in front of it 24/7, and that's all they did, would they be able to detect a issue or bad quality before it actually happened? Chances are they could. So they get so in tuned to the sound, look, feel of it, right? Capturing that knowledge from people like them, and that's what we're really talking about, is putting that subject matter expertise, right? So you don't have, typically you don't have the greatest ETOP packages or turnover packages and FMEAs and things like that. So you might have to go down that process of doing those, but capturing that knowledge.
So that was going to be actually me on my next question. The answer is, I don't have the data to arm this AI model. So how do I create it? You know what I mean?
Yeah.
And a lot of times, if you're buying a legacy asset, which has been a couple of topics here, but just if you're walking in and you're buying a legacy asset, you're not going to have the SME. You're not going to have, Joe that runs it every day. He's not going to be there. So how do I get it?
Yeah, so that's a great question, and that's probably outside of what is a cost is probably the number one question is how much data do I need? And the response is, well, I don't know, first of all, but it's not measured in time. It's not saying you need 1,000 batches or 1,000 runs. It's not measured in gigabytes. You give me 10 gigabytes, I'm going to give you you can build a great solution. It's really in how much variance of the data have you captured, right? So give you an example, we've done some projects where we're doing an autoclave, and we're just doing anomaly detection on a very critical, as part of a risk reduction for an autoclave, right? Where we just want to say, hey, I just want to know when something is anomalous, batch over batch, so steam traps, check valves, pressure, and things like that. We only needed, maybe 3 or 4 days worth of data because we were confident we've seen every variation, every cycle, everything, every different cycle type and things like that, right? Whereas we get into the fermentation process, we need a lot more data, right? When we're predicting what the batch quality is going to be, we actually use 5 years worth of data. So it really depends on, the answer to the question you're trying to ask is how much data you need. But my recommendation, and specifically for pharmaceuticals and biotech, is these industries are what I call data rich, but insight poor, right? So there are silos of data everywhere in our industry, right? Chances are you're in a very good place to start answering these questions with the data you already have, because there is a tendency, and with IoT being a buzzword and these new low-cost sensors coming in, just to put sensors everywhere, which is great, right? But figure out if you can solve that problem to the level of confidence you need with the existing data you have. The analogy I give is a simple pump and motor, which pretty much every facility has, is the initial reaction is I'm going to put vibration sensors on, which is great. I love vibration, but if I already have, it's on a VFD and I have the power, the current, the torque on it, I can do a lot with that data before I even add another sensor, and very often predict the health of that piece of equipment without adding an additional sensor.
I think the other question that comes in, and I think the compliance and the GMP part, quite frankly, remember, if it touches product or impacts product, it's key, right?
Yeah.
And we're not talking, assay limits. We're talking about like steam temperature, steam pressure,
Correct. Yep.
temperature off a chilled coil. I mean, so
Absolutely.
from them compliance implications, adding AI to something like that in a validated and compliant, how do we get around that, or what's been your experience?
Yeah, so it has been very positive, and as we talk to the regulatories, they're very supportive of this type of technology, right? And the analogy I give is, if you were to sit there, the analogy of that operator sitting there, and all they did was feel this pipe for any deviations, right? We're just essentially augmenting that person doing that. And I don't like to use the word bot or agent or something like that, but that's essentially what it is you created this model that's sitting there, and there's a sensor grabbing that data now instead of someone and analyzing that data. I would love to get to the point where it's common practice, and I think we'll get there, especially with the drive for continuous manufacturing, where AI is making recommendations and making those changes, slowing down a machine, turning up a speed, increasing the airflow rate, right? But that's an evolution. Other industries are getting there, and I think it's important from us in the pharmaceutical industry that we start looking outside of our industry, right? Even, and I'll give you an analogy, even nuclear, which is a very and equally debatable, heavily regulated industry, is starting to do closed loop AI control, right? Where AI is making those decisions and doing it, right? So there is a validation process and due diligence from quality that you need to go through, but the challenge from what we have seen is not as big as one might think.
Well, I mean, in our industry, I mean, I think I look back to loop control. I mean, if you're in the solids dosage, there is a loop control. There's
Absolutely.
feedback mechanism.
Absolutely.
And
Absolutely.
Controlling a coil, there's a feedback. I mean, how do you, the key is to get them all. What do I do? I mean, I got a loop control, so how do I add AI on top, or what happens?
Absolutely. A great application for AI is sitting on top of what we'd call APC, Advanced Process Control, or Model Predictive Control, and helping make those decisions to, like a simple PID loop, where it's looking at modulating a valve automatically, right? It's no different. It's just the PID loop has been around 60, 70 years, right? That the whole tuning method, right? This is just a new way of advancing that existing technology, right? And it's just like that, just like you would validate any typical machine or software package, you're looking for that repeatable result and over and again, which AI can give you.
The other thing that I know we get into, and I actually, it came up in the last discussion. I mean, there's still a point where, process logic control is considered, sacrosanct, don't touch it,
Absolutely.
locked down, you got to have dispensation from the Pope to touch it.
That's right, yep.
My question is, all right, AI sounds like a great point, so do I have to play with that part, or what do I have to do?
In every single project we've done, we've never changed a single line of code. And the way I describe it to quality people is that I'm just listening to this PLC. So just like if you had to add another HMI onto the existing PLC, or heaven forbid another dot matrix printer, which still exists, right, and is still printing out reports, right? It's simply to that. The challenge when you get with legacy assets, you can't add new hardware onto it, but chances are there's a port that's there to configure these PLCs, and it's no different than if you were to troubleshoot, say something went down, and the automation person was to walk up, install their laptop, take data, and start to look at it. That's no different than we're doing. So we're not changing a single line of code or anything like that. We're just simply listening to it, just like a maintenance or automation person would.
I mean, one of the things I always try to tell people is the PLC is just a loop control that's on steroids. I mean, to me, it's not different than a standard, but you know that.
That's right.
I think it's the code's what the magic is here. You know.
Absolutely right. Yeah.
Right.
And that code literally came out of some person's head. And put that in there, right? So we're just complementing that and augmenting what someone designed to be modern.
Right, and you know, it's just I've had this discussion, right? You try to explain them about volt ramps on a PID, and it's the same thing, and they look at you like you're nuts. And I said, you know what? End of the discussion.
That's right. Yeah.
I get it. So we don't have to upgrade.
No.
We're good.
Nope.
All right, that's good. So, okay. So AI sounds really cool. Really, it's obviously, you know, we're talking Pharma 4.0.
We're absolutely talking Pharma 4.0.
Okay, so what do I got to do? I mean, what do I got to do? Who do I engage first? Who do I train? The engineer, the operator? I mean, what's going on?
Yeah, so it's, you know, you're assuming you've done some AI, and you've had those people that are going to what I call consume those insights, involved in that process, you know, to help build that miles to empty analogy I was talking about. And I think really, and what we set out to do was design a platform that is designed for the people that are on the shop floor, what industry is now calling OT, operation technology, right? Those people that are familiar with using MES systems, or even go down to PLC systems, right? The same look and feel, so those people can start to use it, right? We designed the platform to be not, so you don't have to design a rung of code, right?
Yeah.
So it's all about training or enabling what they already know to do it, right? I don't think we're going to get mainstream AI adoption by training everyone to be data scientists, right? I think what's going to happen is we need to enable those data scientists to work with SMEs on a common platform to put that forward.
Okay, just to back up, when you say OT, you're not talking about overtime then?
No, and my first introduction into OT was I went to a meeting and I sat down beside IT, that we all know IT, we got that, right? And I sat down in a meeting and there's IT there, and the guy conducting the meeting goes, okay, you're IT and you're OT. And I'm thinking,
overtime.
Okay, overtime, yeah, okay, you're gonna pay me, this is great, this would be great, right? Out of time, I was trying to figure it out, right? And they're like, you know, you're operational technology. Oh, okay, I get it. I'm the automation guy, okay.
I got it.
Yeah.
As opposed to the process guy.
Yeah.
Okay. So, one of the other things that and it's kind of a common theme here, and we were talking about, you know, augmented reality applications. One of the things was return on investment. If I'm going to put this stuff in, I got to create certain. So how do I pitch AI on a return on investment? I mean, what's the deal?
Yeah, and there's an incredible return on investment, and AI, I can tell you, and generally is going to be less costly than you think. When we're looking at ROI, where we typically have people start is on those critical assets, those bottlenecks, typically in a risk reduction type project. With artificial intelligence, you can have results, improve those results without even streaming a single piece of data, right? So typically how we start projects is we look at that and we start projects by using CSV files. So most of that disparate data sources you have out there from your quality systems, your automation systems, you can get data into a CSV file, experiment, say, hey, with this amount of data, can I detect this or can I predict this? Right, and it's really up to the end users to say what that value is. What is the return on predicting what a batch is going to be 3 days from now, and course correcting that during it, right? And pharmaceuticals quite high, but you can make a very, very low cost investment to prove those results before you even put any like what's called edge hardware in and IoT sensors and investing in the platform. Right, is you can do all these experiments with CSV files before you invest to prove that ROI.
So getting back to the operational aspect. So one of the things that we talk about a lot is operational excellence.
Hmm.
So, but again, that's like OT. I mean, OE, OT. I mean,
Yeah.
I think what we need, let's just ground that in what does that mean in the context of AI? I mean, what does that mean?
Yeah, so the analogy I use for that is most of us, even outside of this industry, will have some side, depending on maturity, will have some sort of OEE measurement, which is telling us how well we're making that product, how much we're making of that product towards its design plate, right? But OEE is a lagging number. It's already happened, right? And really what AI is bringing us into is not what has happened, because I can't do anything about the past, right? But what is going to happen? So if we say, hey, your OEE is 85% right now, but 2 hours from now it's going to be 70, then you have time to course correct, right? So operational excellence to me and to us is no longer what has happened. Do I have operational excellence? Do I have the uptime? Do I have the availability? Do I have the quality? It is, will I have that in the future?
And AI is going to give us that,
Yes.
right? Okay. So let me just see. So it really turns out that the criticality of the asset that you're dealing with, and what are the criteria? I mean, bottom line is, should that ROI be? I mean, if I was telling them, for example, criticality, if I could assure content uniformity on a regular basis, that'd be a no-brain sell, right?
Right.
So, but we're upstream in the process now. So the question is, of all the assets we're talking about, PIDs, the question, what other criteria should I use to select assets so that I can argue the ORI for AI? Is there
Right.
something else?
Yeah, there's a bunch of things to look at, and as I said, a lot of people look at risk reduction. Criticality has a big impact on it. We are different than other industries where if you look at oil and gas and other industries where if you have a bottleneck, a very high risk single asset that is a bottleneck, in other industries they'll just say, I'll buy another one. I can literally buy another one, put it in a few months, right? In our industry, we had to validate it, go through quality. 10 years from now, I might have that same asset in there, right? So you need to look at the overall criticality, the return on investment, the risk reduction. There's a bunch of things. And also specifically where to start, and hopefully I'm not beating to another question, is where to start. It might not necessarily be the most critical asset, it'll be where can I get the quickest return to prove the value to then scale to other assets.
And I got to say, one of the things I perceived right away is downtime.
Absolutely.
To me, if I'm down, because you got to remember the way the downtime criticality works is it's calculated based on market realized sales.
That's right.
So they come back with this astronomical number, and so I mean, to me,
Reducing downtime. Every single project I've done, which has been many over the last few years, has started with that in mind. With how do I reduce the downtime? How do I get from less reactive into planned maintenance? Even if I know it's going to break, at least I can plan for my end of run and things like that, right? But quickly people are going from solving downtime, and I've done what I can. Now AI is not going to change the design of an asset, right? So if you have a fundamental issue that's causing reliability issues, AI is not going to replace that, it'll help identify it, but you might have to do some redesign efforts, which is not an easy task. But a lot of our customers have moved from that downtime into the production quality side. As we talk about adding intelligence to asset, typically people start with the downtime and then quickly graduate to add more intelligence onto the quality and process side of it.
just as an aside, I mean, if I'm going to buy a piece of process equipment, and we're talking one that's capable of 6 or 7 inputs, complex, not
Yep.
So does this come? What has been your experience? Does that come from the suppliers with AI layered on top of all of the systems, or not?
No, and I wish it did. I wish it did, and I wish it was obviously from us,
Yeah.
of course. But I wish it did. And then my challenge to anyone buying it is ask those equipment suppliers to. It doesn't have to necessarily come with AI on top of it, but be able to easily add AI on top of it, right? So be able to extract that data out of it. Specifically as OEM vendors, if they can capture the failure signature of these assets, right? And I think a lot of value from OEMs is owning that data. They are the experts on that equipment. They design that equipment. They're testing that equipment. If they can capture that data and provide it as a package to the end users that we can then use AI on top of, is going to be very beneficial.
So it actually sounds, if that was a bolt-on option, it would probably be to my benefit then.
Absolutely, and I think we will get to that point very shortly where it is going to be, and we've seen it through companies requesting OEMs saying, please have this or bid on this being Industry 4.0 or Pharma 4.0 ready.
Gotcha. All right, having said all of that, one of the other things that comes to the forefront is, so you got a couple of techie, bright process guys, a bunch of engineers, but remember, in our industry, we got to sell it to QA,
Absolutely.
we got to sell it to IT, we got to sell it to God knows who else.
Yes.
Other than the ROI, because that's only one hurdle. The other hurdle is convince the quality assurance manager that he's not going to go to jail. So the question
Sure.
is, what else do I got to do to get these guys on my side?
Yeah, and what we found is donuts and coffee go a long way along these projects. So typically, and that's a joke aside, but typically, our projects.
Well, it's pizza and beer in Jersey.
Okay, sure. I'm Canadian, so we do coffee and donuts, but
no poutine.
No, that's a
okay.
Quebec thing.
Okay, gotcha.
Typically they're driven from an engineering deployment, but we get them involved early in that process, and specifically from a quality aspect, they start to see what the retention of that data looks like, even how they can use that data in the validation. So my advice is get them early on. And what I have found surprised me, coming from an Industry 3.0 automation background, where I fought day in and day out with IT on I want to do this, and you want to put this here, you want to put this there, is often IT is at the leading edge of Industry 4.0, and when you go to them as, hey, I have an Industry 4.0 solution, they have been more receptive in the last 2 years because they are somewhat leading these initiatives, because it really is a data flow, which they own the data flow in through our architecture. They are more receptive than you think they will be in terms of opening up ports and getting data out.
And I think the other point that is going to come about is like, it doesn't cost a lot to keep data anymore. Let's face it.
No.
So these things do or do not have to be cloud-based.
Yeah, good question. The cloud has come synonymous with Industry 4.0, and I am a big supporter of the cloud when it comes down to security and things like that. But at the end of the day, cloud is more than storage. Cloud is distributing computing, right? We think of it as storage, but it's more than, because Google Photos and things like that. Cloud is the access to the horsepower of many machines as you want, right? But if you can provision those machines, what's called the fog, which means it's still within your premises, and data doesn't have to leave your premises. You can deploy artificial intelligence on your premises without having to send data outside of your firewall into the World Wide Web, and that does alleviate a lot of the concerns that quality, IT, even lawyers from intellectual property. Is this our batch recipe going to get out there? No, it's in your walls, you control it, right? It takes a lot of data to train a model. It does not, a lot of horsepower to train a model, or AI, it does not take a lot of horsepower to actually run this model on streaming data.
But what it does is it bumps up your computing power.
Absolutely, yeah. And we've had a lot of instances where I thought it'd be an issue, but for these companies to provision a virtual machine, which they do every day, on the horsepower required, and it's not GPU size, if you know what that is. It's not these incredible ones, right? We do have some applications where it's incredible horsepower required because it's doing a very advanced prediction. The lights dim down when it starts to do it type thing, right? But most things are doing anomaly detection, predicting what the quality of a batch is going to be. You may even be able to run it on a cell phone, right? And there's AI running on your cell phone right now, right? So, as compute power comes more and more available, it's going to be easier and easier to do it on premises. To the fact where I think we'll get to the point where automation is going to have embedded AI right at the PLC level. There's going to be a little AI card you stick next to your processor, and that's going to run the algorithm in there.
So the AI, so let me make sure. AI runs all the time. It doesn't model on down. In other words, it doesn't wait to downtime to draw down on. When it draws its most computing power, it's all the time. It's not off.
No, it's only when you're training that model. When you're training on those. But once it's running, you've trained it.
Yeah.
Right. It doesn't. It's just putting those inputs, saying, is this normal? Is this normal? Is this normal? Is this okay?
Yeah.
Right. And it's just looking at that data to train a model on 5 years worth of data and stuff. That requires some horsepower, depending on how much you're doing.
Okay, but that's a spike.
That's a one-time spike, but it is a continuous learning process, and AI gets smarter over time. There's a little bit of hype on continuous learning, which is almost true, right? But it does get smarter over time. How it gets smarter is interaction from us. Yes, AI, you've done good. That was a good prediction, or no, that was bad. In our platform, it's literally a thumbs up, thumbs down saying no, this wasn't a good detection or prediction. Maybe I didn't train it with enough data. It hasn't seen that data. I'm running a new batch, new raw materials, whatever it is. It needs to be retrained.
Blair, thank you very much.
Absolute pleasure. Thank you, Russ.